Hi folks, so this is scatter graphs. So it's a simple enough concept. Let's look at just these three examples first. So these are things that could be put onto a scatter graph. So it's always going to have two events. So the sale of ice creams as the temperature rises. So the two events here are sale of ice cream and temperature rising. So you should be able to see that as the temperature rises during the summer. So as the temperature goes up, well then the sale of ice creams will also go up. So depending on how hot it is, generally speaking, the sale of ice creams will get more. So this is an example of two things going up together. So that's an example of positive correlation. So that's positive. Let's look at the second one. So the value of a mobile phone as it gets older. So value of a mobile phone and as it's getting older. So as a mobile phone gets older, so as it goes up in the years, think about, do you think a value of the mobile phone will get more or will get less? Well, it's always going to get less. So the older it gets, the more the price or the value comes down. So therefore, as one thing goes up, the other thing goes down. So that's an example of negative correlation. And I'll show you what these look like on a scatter graph in a minute. But these are the types of correlation. And then let's look at the third one. So the amount you'll get in your maths test, the further you live away from school. So one thing is your grade in your maths test, the other thing is how far you live away from school. So you should be able to see, as there, because the two of them are pretty much independent, there's no actual correlation there, so no correlation for that one. So if you live really close to the school or if you live really far from the school, it shouldn't really matter or shouldn't affect how much you get in your maths test. So that's the three types of correlation. So if you look over here then, this is what they will look like on the graph. So on a scattered graph. So that's positive correlation. So positive correlation is always going up from left to right, so it's just always rising. Negative correlation is going down from left to right, and in no correlation, all the dots or the x's or whatever will be everywhere on it. So that's the difference between the three of those. So you just have to know what they look like on the graph. So a line of best fit then is something you can be asked to draw in this. It's a simple enough thing really. It's just a line that goes through basically the middle of the dot. So it's the line that best represents the data on the scatter graph. So it may pass through some of the points, none of the points, or all of the points, but when you're drawing it, you're just trying to draw it in through the middle of all of the dots pretty much. So that's line of best fit. So this is an example of something you could put on a scatter graph then. So these are the marks that students got in maths and science tests. So you see there, student A got 56 in maths and then got 62 in science. So you see there the maths is along the bottom, the science is up the side. So it's a simple enough idea, you're just plotting where they are. So if I go to 56 for maths and 62 for science, I will get, it'll be about there. So that would be that student. The next one, 73 and 68. Will be up here. 51 and 45. So I'm being rough enough here now. Is there, so 62 and 68. So I go across to 62 up to 68. Up there, 24 and 35 there, 67 and 73 is up about here, 94 and 98, sorry 88 is up here, and then 35, 32 is here. So roughly enough, so you're not going to be penalised if you don't have the x's exactly on where they should be. So you'll see there that because it's rising from left to right, so it's, if you look back up which one of these it is, it's a positive correlation. So that means that generally, if you did well if you got a high mark in your maths test, you also got a high mark in your science test. Or if you got a low mark in your maths, you got a low mark in your science. So if you look at each individual one there, that backs it up. For example, the last student there got 35 and 32, so they're poor marks in both of them. But this student G got 94 and 88, so they did well in both of them. So there's a positive correlation there between maths and science test results. Now, if I was drawing the line of best fit, it would probably go in here. So again, you're not going to be docked marks if you don't get it completely right. Now, one mistake some people do is they draw it from 0, so it doesn't have to go from 0. Now here it's not far off, but you don't draw it from 0, so it doesn't have to go through that point, or it shouldn't go through that point most of the time. Right, so last thing here. So you can also be asked for a correlation coefficient. So if you look at these ones here, the correlation coefficient, if it's a perfect negative correlation, because they're falling from left to right, so that is a correlation coefficient of -1. And then on the other side, this one down here, it's a perfect positive correlation. X's are going up in exactly a straight line, so that's a correlation coefficient of 1. So this one here then, it's fallen from left to right, but now they are pretty close to each other, but not quite. So this one, for example, is well away from it, so this will have negative then, so, and it's 0.7. This one is no correlation at all, therefore it's 0. So it's on a scale of 1 to -1 pretty much, and 0 in the middle is where there's no correlation at all. This one, it is a positive correlation, but they're fairly well spaced out there from each other, so therefore it's 0.5. And then the last one we've already said. So that's the difference between correlation coefficients. Now you could be asked to try find correlation coefficients as well, so I'll show you how to do that on a different video, but you have to use calculator for that. So that's it. That's the basics for scatter graphs and correlation.